Welcome to MathTopia Academy. My name is Holly, and today I'm going to show you how to solve problems 21 through 30 from the 2025 Math Kangaroo Level 7-8. In the six-digit number PAPAYA, different letters stand for different digits, and identical letters stand for identical digits. Furthermore, y equals p plus p equals a plus a plus a. What is the value of p times a times p times a times y times a? To start, we know that y equals p plus p, or 2p, which equals a plus a plus a, or 3a. This means that splitting this up into two equations, we have y equals 2p and y equals 3a. Since y, p, and a are all digits and therefore integers, y equals 2p means that y is a multiple of 2. Similarly, y equals 3a means that y is a multiple of 3. Since y is both a multiple of 2 and 3, y must be a multiple of 6. And since y is a digit, y must equal 6. Y cannot equal any multiple of 6 greater than 6, because the multiples 12, 18, 24, and so on are not single-digit numbers. Now that we know that y equals 6, we can find p and a. So 6 equals 2p, which means that p equals 3, and 6 equals 3a, which means that a equals 2. Now we know y, p, and a, so we can find our product. We're looking for p times a times p times a times y times a. So 3 times 2 times 3 times 2 times 6 times 2. And to make this easier to solve, we can group some numbers like the 3 and 2's, and then the 6 times 2, so we have 6 times 6 times 12. And then in a similar way, we have that this equals 36 times 12. And we could multiply these two numbers out, or we could realize that 12 equals 10 plus 2. And then we can distribute our 36 to both the 10 and the 2, getting 360 plus 36 times 2 is 72. And our sum is 432. Or A. Manuela shoots at a goal a total of 17 times in 2 soccer training sessions. In the first training session, she hits the goal with 60% of her shots. In the second training session, she hits the goal with 75% of her shots. How often does she hit the goal in the second training session? Well, the number of goals that she attempts in training session 1, we can call it A, plus the total number of goals she attempts in training session 2, we can call that B, equals 17. And of the A shots she takes in the first training session, she makes 60% of these. And out of the B attempts she takes in session 2, she makes 75% of these. She has to get a whole number of goals, so to make the math easier, we can turn these percents into fractions. So 60% equals 3/5 and 75% equals 3/4. Now we know that for the total number of goals that she actually makes, she has A attempts in session 1, and of these A attempts she makes 3/5. So her total number of goals is A times 3/5. And similarly, she has B attempts in session 2, and of these B attempts, she makes 3/4. So B times 3/4 is the total number of goals she makes in session 2. Now, she has to make a whole number of goals, so A times 3/5 must be a whole number. So A has to be a multiple of 5. b times 3/4 also has to be a whole number, so b has to be a multiple of 4. Now, we know that a plus b equals 17, and a is a multiple of 5. So if we have a plus b equals 17, and b is a multiple of 5, or a is a multiple of 5, excuse me, a can be 5, 10, or 15, and then we'll add some number b, and this will give us 17. So b could be 12, 7, or 2. But since b has to be a multiple of 4, the only multiple of 4 we have is 12. So a has to equal 5, and b has to equal 12. Since she attempts to make a goal 12 times in session 2, and she makes 3/4 of those shots, she makes a total of 9 goals throughout session 2. So our answer is D. Luis places 3 rectangular pictures as shown in the figure. What is the size of angle A? To start, it's important to note that if we have a straight line, which is 180 degrees, and we draw a corner touching it, which is 90 degrees, we've created 2 smaller angles, which we can call X and Y. And we know that X plus 90 plus Y must equal 180 degrees. So X plus Y equals 90 degrees. And this is just an important side note that we can refer to later when solving our problem. Now looking at our actual diagram, we see that we're going to have to do some angle chasing. And what I always find super helpful to do in angle chasing is to create triangles, because triangles will always have an interior angle sum of 180 degrees. So by extending this picture right here, we've actually created 2 triangles, one here and one here, and the sum of those interior angles is 180 degrees. Now we can start our actual angle chasing. So we have a corner right here, and looking back at our side note, we know that this angle plus 62 is going to be 180, so this angle is 28 degrees. We also have a corner right here, which is 90 degrees, so this angle must also be 90 degrees because 90 plus 90 is 180. And since we have a triangle right here, we know that this angle plus 90 plus 42 is going to be 180. So this angle has to be 48 degrees. Similarly, we know that this angle plus 48 degrees must be 180 degrees, so this has to be 132 degrees. Again, we have another triangle right here. So this angle plus 28 degrees plus 132 degrees is 180 degrees, so this angle is 20 degrees. And we have another corner right here, so we know that angle A plus 20 degrees is 90 degrees, so angle A must equal 70 degrees. A neurolog lives 1 kilometer from his school. He sets off for school at the same time every day. If he walks at a speed of 4 kilometers per hour. If he cycles at a speed of 15 kilometers per hour. When he walks, he arrives 5 minutes before school starts. How many minutes before school starts does he arrive if he cycles? A good way to start this problem is by figuring out how long it takes a neurolog to walk to school. So we know that he walks at a speed of 4 kilometers per hour. This is the same as 4 kilometers per 60 minutes, since there's 60 minutes in an hour. And we know that his school is 1 kilometer away. So we need to figure out how many minutes it takes him to walk 1 kilometer. If we simplify the fraction 4 kilometers over 60 minutes, we get 1 kilometer over 15 minutes. So it takes him 15 minutes to walk to school. And in addition, we know that he arrives 5 minutes before school if he walks. So adding 5 minutes to this, we get that he must leave his house 20 minutes before school starts. Now, if he cycles to school, he cycles at a speed of 15 kilometers per hour. This is the same as 15 kilometers per 60 minutes. And his school is 1 kilometer away. And simplifying 15 kilometers over 60 minutes, we get 1 kilometer over 4 minutes. So it takes him 4 minutes to cycle to school. Since he sets off for school at the same time every day, he has to leave 20 minutes early. And if it takes him 4 minutes to cycle to school, that means that he arrives at school 20 minus 4, or 16 minutes early. In the rectangle ABCD, the points E and F lie on the side DC, so that angle EBA equals angle DFA equals 45 degrees, and AB plus EF equals 20 centimeters. How long is the side BC? Well, to start, we know that AB and DC are parallel since they're part of a rectangle, which means that if this angle is 45 degrees, this opposite angle must also be 45 degrees. And likewise, if this angle is 45 degrees, then this opposite angle must also be 45 degrees. That means that these two angles must be 90 degrees, and we've created a 45, 45, 90 triangle. Now, by dropping this altitude right here, we've created a 90-degree angle, so we know that this must also be 45 degrees. We can do the same thing in the diagram above. So we have this altitude creating a 90-degree angle, and this is also 45 degrees. Now we've created more 45, 45, 90 triangles. So we'll notice that if we call this side length A, then this altitude must also be A. And on this side, we have A as well. And going to the diagram up top, if we have this side length, which we can call B, then this altitude must also be B, and this side length must be B. So now we know that AB plus EF equals 20. So 2A plus 2B equals 20. And we're looking for side BC, which is parallel to the two altitudes drawn. And the sum of those two altitudes is A plus B. So if we divide both sides of the equation by 2, we get that A plus B equals 10. So the side length BC must also equal 10. If the height of a cuboid is reduced by 3 centimeters, its surface area decreases by 60 centimeters squared, and a cube is formed. What is the volume of the original cuboid in centimeters cubed? Well, first of all, a cuboid has a base that is a square. So if we call this side length A, then this side length is also A. We also know that its surface area decreases by 60 centimeters squared. So we're getting rid of this area, the two faces opposite to those, and then this top surface area doesn't actually affect the total surface area of our new shape, because when we remove this piece, we're left with the same area on the bottom, so our surface area is not affected. And again, we know that this has to be of length A, and so does this side. So the total surface area that we're decreasing by is 3 times A for the area of each of the yellow rectangles, and then times 4 because there's 4 of them, and this equals 60. So we have 12A equals 60, and A equals 5. So now we know these side lengths. And we also know that a cube is formed when we decrease the surface area. So that means that this side length is also A, or 5. And then in order to find the volume of the original cuboid, we need to multiply this side length by this side length by this side length. So we have 5 times 5 times 8, which is 200 centimeters cubed. In the quadrilateral ABCD, the points N and K are marked on the sides BC and AD so that BN equals 2 times NC and AK equals KD. The areas of the two triangles ABN and CKD are known. What is the area of the quadrilateral ABCD? Well, first of all, we know that BN equals 2 times NC. So if NC is length A, then BN has to be length 2A. Similarly, AK equals KD. So if AK is a value B, then KD must also be B. Now looking at triangle CAK and CKD, we notice that they have the same base. These triangles also have the same height, which we can call h sub 1. If two triangles have the same base and the same height, then their areas must also be the same. So the area of CAK is also 2. Similarly, we have triangles BAN and NAC. These triangles also have the same height, which we can call h sub 2. And since the base of triangle NAC is half the base of triangle BAN, and their heights are the same, that means that the area of triangle NAC is half of the area of triangle BAN. So the area of triangle NAC must be 3. Now we can add the values for all of our triangles. So we have 6 plus 3 plus 2 plus 2, which equals 13, which is the area of quadrilateral ABCD. Martin wants to fill the cells in the diagram shown such that each cell contains either a cross or a circle. No column, row, or diagonal should contain a series of 4 consecutive identical symbols. What will the gray column contain in the completed diagram? The best way to go about this problem is by filling in each individual cell. So to start, we notice that we have 3 crosses in a diagonal, so our empty cell must have a circle. Then we see that we have 3 circles in a column, so we must have a cross. Then we have 3 crosses in a diagonal, so we must have a circle. Then we have 3 circles in a row, so we must have a cross. We have 3 circles in a row again, so we must have a cross. We have 3 crosses in a column, so we must have a circle. We have 3 circles in a diagonal, so we must have a cross. We have 3 crosses in a row, so we must have a circle. We have 3 circles in a diagonal, so we must have a cross. We have 3 circles in a column, so we must have a cross. And then we have 3 crosses in a diagonal, so we must have a circle. Now our entire gray column is filled, and we see that there are 2 circles and 4 crosses. The letters P, Q, R, S, and T stand for 5 consecutive positive integers, but not necessarily in this order. The following applies. P plus Q equals 69, and S plus T equals 72. Which number does R stand for? The first thing to notice in this problem is that when we're working with 5 consecutive positive integers, the sum of any 5 consecutive positive integers is divisible by 5. For example, if we have 1 plus 2 plus 3 plus 4 plus 5, this equals 15. If we have 2 plus 3 plus 4 plus 5 plus 6, this equals 20. What we're doing to get from these consecutive numbers to these consecutive numbers is adding 1 to each term. When we add 1 to each term, we're adding 1 times 5 to the entire sum. And 5 is divisible by 5, which means our new sum is also going to be divisible by 5. We can continue making consecutive number patterns by adding n to each term, and we'll see that by doing this, we are adding n times 5 to our sum, which is also divisible by 5. So knowing this, we know that p plus q plus r plus s plus t is divisible by 5. This means that p plus q, which is 69, plus r plus s plus t, which is 72, is also divisible by 5. So 141 plus r is divisible by 5. Now we can use the information that p plus q equals 69 and s plus t equals 72. If p plus q equals 69 and p plus q are part of the same string of 5 consecutive integers, that means that p and q must be pretty close to each other. At most, they can be 4 apart. So that means that p plus q are kind of around the same value, and 69 divided by 2 is near 35. So p and q each must be around 35. Using the similar logic for s and t, s plus t must be around the same value. So 72 divided by 2, each number must be around 36. Knowing these values helps us when trying to figure out what r is, because we know that 141 plus r has to be divisible by 5. Values of r that would make this work that are near 35 and 36 would be r equals 34 and r equals 39. I'm going to try testing 34 first because 34 is closer to 35 and 36. So if we create a string of numbers with 34 at the center, we can go 4 up, so we have 35, 36, 37, and 38, and then 4 behind, so 33, 32, 31, and 30, and 34 is what we think is our r value, and then we need to test if there exists a p and a q such that p plus q equals 69, and then an s and a t such that s plus t equals 72. And we actually see that this works. So we have 33 plus 36, which equals 69. So this is like our p and this is like our q. And then 35 plus 37 equals 72. So this is like our s and this is like our t. So now if we take this set, 33 through 37, we see that we have 5 consecutive positive integers who there exists a p and a q and an s and a t, which means that our r value must be 34. So our answer is that r equals 34. But if we happened to test 39 first, we would see that we wouldn't get a set that satisfies the conditions of p plus q and s plus t. So then we would know to test 34. And ultimately, we find that 34 is our answer. The friends Annie, Bibi, Clara, and Doris each live on a different floor of a 4-story building. There are also other people living in the building. 25 people live above Annie, 5 people live below Bibi, 17 people live below Clara, and 22 people live above Doris. How many people live in the building in total? Well, first of all, we know that 25 people live above Annie, and 22 people live above Doris. Since more people live above Annie, Annie must be on the bottom floor, or the ground floor. Similarly, 5 people live below BB, and 17 people live below Clara. Since more people live below Clara, then Clara must be the top floor. Now we have to figure out where BB and Doris live. We can do this by guessing and checking. So, for example, if BB lives on floor 1 and Doris lives on floor 2, we can check by knowing that 25 people live above Annie, so there must be 25 people on these floors total. 5 people live below BB, so there must be 5 people on the ground floor. 17 people below Clara, so 17 people must live on the bottom 3 floors. And 22 people above Doris, so there must be 22 people on the top floor. We can see that this doesn't work because 25 plus 5, which is all of the floors, does not equal 22 plus 17, which is also all of the floors. So we know that we have to swap BB and Doris. So instead, we have that BB lives on floor 2 and Doris lives on floor 1. Now knowing this, we have 22 people live above Doris, so 22 people on the top 2 floors, and 5 people live below BB, so 5 people on the bottom 2 floors. 22 plus 5 is 27, which means that there's 27 total people in the building. I hope you enjoyed these video solutions. As you prepare for your next math competition, check out these other great resources now available on Amazon.